Okay, so for my dynamic systems project, I analyzed the front suspension in my mountain bike as a mass spring damper system. Modern mountain bikes have several adjustment knobs to adjust the damper response, and I wanted to find out how these knobs actually affected the dynamics of the system. I found the spring constant on my fork using a bathroom scale, and then I measured the acceleration time response using the accelerometer on my phone. I repeated this test for 3 different rebound settings: a high speed, medium speed, and low speed setting. I then filtered and plotted this data, and I was able to calculate 3 different equations of motion for the different tests that I performed. Here's the data. You can see that the peaks are labeled on the graph. I used the code to find that. And then here's the code I used to find the equations of motion. Here's the displacement graphed, as well as the velocity. So basically, from performing these tests, I found that the higher the rebound setting, the lower the damping ratio, which is what I expected to see. However, my damping ratios were very close together. I believe this was due to some error in part from the way I had the phone mounted to the bike, as well as how I used the log decrement method and the guesses that I made when finding the damping ratio. If I perform this test again, I would mount the phone more securely and possibly put the bike in a test rig, or take the fork out entirely and just test the fork by itself instead of having to worry about the kinematics of the bike as well.